Sorry.
Okay, thank you. Good afternoon. My name is Marilyn Barger, and welcome to the Smart Manufacturing Workshop. I'm the Executive Director of FLATE, the Florida Advanced Technological Education Center of Excellence. FLATE was funded as an NSF ATE regional center in Florida, supporting advanced manufacturing education in the two-year college programs for 15 years. Just about 1 year ago, we transitioned to our Florida MEP, the Manufacturing Extension Partnership, which is NIST funded through the Department of Commerce. We also have funding to support us from the Florida Department of Education, their Perkins Leadership Grant. So this work comes to you from all of those folks. And right now I'm going to report on an update from last summer on our Future of Work Caucus. All right, so as a project overview, we had a diverse team. These were FloridaMakes and some college partners who helped us recruit industry and the college folks to participate both in all of the work that we did, which I'll explain more of as we go through. Okay, the goal of this project, this was a small project, very focused on identifying the technologies in Florida's small to medium manufacturers that contribute to Florida's technical skills gap. And so that particularly we focused on the new and emerging technologies in Industry 4.0. And after some research, we settled on this version of Industry 4.0 from the Boston Consulting Group. And the 9 technologies that they identified as strong contributors to Industry 4.0. So going around the loop from the top, autonomous robots, simulation, horizontal and vertical integration, industrial Internet of Things, cybersecurity, the cloud, additive manufacturing, augmented reality, and big data and analytics. And we'll talk more about those as we go through that identify the skills gaps. So the activities of this particular project were changed due to COVID. We had planned a one in-person all day or day and a half event to gather our data from industry and educators, but that didn't happen. So we shifted to the process that you see here. We did this research on our Industry 4.0 technologies. We decided to develop a questionnaire for industry and separately for the educators and collect data that way and analyze that survey data before we had a virtual event, which obviously would be much shorter than a day and a half event, in-person event that we had originally planned. So then we reviewed the input and feedback from the caucus and look for curriculum gaps in our Florida frameworks, and then disseminate and implement our findings, of course. So the questionnaire was pretty straightforward. There was some demographic information requested from the companies, what sector, where they were located, numbers of employees. And then the important question was around the work skills. We'll talk a little bit about that in a future slide coming up. How many technicians they were hiring and students that were graduating, and the levels of those technicians. Were they entry, mid, or higher level, highly skilled technicians? And then we also slipped in a question on the importance of industry credentials and which credentials they valued. So going back to the Industry 4.0 technologies, we identified, the leadership team identified 4 of those 9 from the Boston Consulting Group that we felt the entry-level technician, so this would be a graduate from a 2-year program, a technical program, would come face-to-face with as soon as they went to work. And again, starting at the top, autonomous robots, simulation and simulated experiences, and like digital twins, et cetera. Industrial Internet of Things, which includes all the sensors, which the technicians would be involved with, and then additive manufacturing. So for our purposes, we focused on those four, not that the others are not important, but we felt like they were a little bit above at this point in time, the skill level of the entry-level technicians. Okay, so now we're going to actually look at those questionnaire responses. We did have 133 manufacturers respond from all over the state, pretty good geographic distribution, and 26 of the 28 colleges. These are that offer the 2-year engineering technologies degrees. The questions were worded like this to be clear for the manufacturers and for the educators. The question about the technologies and skills that the technicians would need, we asked them to pick the top 5 technical skills, technician skills that were in our list that were being impacted, would be impact the technicians in their company within the next 5 years. Then for educators, it was just worded slightly differently, but they had the same list. We asked them to select the top 5 technician skills that they felt will be impacted by emerging technologies in their service area within the next 5 years. So what was coming down the pipe for the graduates and what was industry expected to see. I do have this little animation of the data analysis that we went through. I think you'll have to check your volume on your computer to hear the commentaries on this. So I'll just warn everyone ahead of time for that. Hopefully everyone will be able to hear.
Manufacturers have identified 15 skill areas. Survey information has been acquired from 133 manufacturers and 21 of the 23 colleges that service these manufacturers. This information has been filtered, sorted, and analyzed to identify skill gaps in high demand areas of concern to manufacturers.
Okay, with that, could you hear the audio? Awesome, thank you. All right, so remember we picked 4 of those 9 Industry 4.0 technologies, and they're here color coded in different, slightly different colors. And the particular sub skill sets of each of those are on the right associated with each one. So you'll see under autonomous robots, for example, that we picked out programming as an important skill, systems integration, and robot repair. And then under simulation, there's some kind of higher level skills under simulation, perform root cause, planning and evaluating processes, compare and contrast process alternatives, recommend new situations and their effect on processes, and participate in developing existing and new products and operations. And I won't read the rest, but you can see those specific skills. They'll be on the slide again here coming up, but I'm gonna move on. So next you'll see the kind of raw data, I would call this, the percent of manufacturers that picked as one of their 5 each one of these skill areas in these different technologies. And so you don't have to analyze that yourself. We'll just move forward and take a look at those. But first I want to go through the criteria that we used to do our sorting, as Richard announced during that quick little video. So once we got those summary numbers, we looked at which skills were selected most often by manufacturers and those that were selected more often by educators. We picked a cutoff point of 30%. If there were not enough responses that selected a particular item, we eliminated it for the purposes of this project. We're trying to find those most in need that produced a skills gap. And then we looked for ones that had big gaps between the manufacturers and the educators, either way, to see if that was, to try to discover if those were communication errors or misconceptions between the 2 groups or whatever was happening there. So going back to our chart, this table has eliminated all the ones that had fewer responses than that 30% of each group. So those have been removed from this particular table. And then we look for those criteria that I just mentioned, ones that the manufacturers thought were most important, that the educators thought where there were the biggest gaps, and prioritized those for our discussion at the virtual caucus. Okay, then we went to the caucus. That's where we are in that yellow highlight there. So come back, and in the caucus, after reviewing the demographic data and looking at the what Industry 4.0 is, we had discussion around these two questions for those prioritized skills. Again, they were just prioritized for the caucus because we only had a 2-hour window to discuss this. We asked what the technician's role was with that particular skill and what skills they needed in that role. What were they actually going to be doing? It turned out that those two questions kind of collapsed into the same responses from the participants of the caucus. We asked them to submit their responses in the chat, and a few chimed out with their microphones. And we captured all of that from both from the recording and the chat window. And this is just kind of a sample of how we looked at the data after the caucus. So what the team did, the project team did, was go into each of these sets of questions and identify the keywords, coded the responses based on frequency of use. So in this one, you'll see programming, troubleshooting, problem solving. Oops, my goodness, sorry about that. Let's go back, etc. And when we got done with that, for all of the 5 different skills we discussed that day, we aggregated them together, and we ended up with this list of 37 skills that the manufacturing technicians of the future would need. Now, many of these look like skills that we might need today, and that's probably true in some facilities. I'd like to warn you that this list is only arranged to fit on the screen. There's no prioritizing here or groupings in this particular list. There's just the 37 skills that we identified from all of the feedback we got from the caucus. And then remember that the caucus was fed by the results from the surveys that we had distributed earlier. So what came out of that particular analysis was we had these 6 categories. 6 categories were identified that we isolated those skills into. The skills were not unique. We used them in any of the categories that they fit. So some skills ran across all 6 of these categories. So interpersonal skills, still important, otherwise known as soft skills. Problem solving, both for quality and for maintenance. A lot of quality issues popped up in the caucus. Systems integration, prototyping, big data, and analytics. And the one that was probably most scary to us as we got to this point was the big data and analytics, because we weren't sure that we were addressing this in our 2-year program, and thinking we might have something to deal with there. So those 6 categories emerged from our 37 skills, and then we took on